Welcome, everyone. Thank you for taking the time today to join me for this virtual webinar. We're going to be spending the next half hour on some strategies and activities that you can use immediately following the session to assist you in teaching space or astronomy. I'm really excited to share what I've planned for today, and I hope you can try some of these out soon with some of your students. I like to have goals with my session, and it really starts with the agenda. So I'll begin to talk briefly about the importance of space, science, and anatomy. This is kind of like a great starting point. My intent is to kind of touch on this and really set a foundation for the importance of what we're learning together. And then we'll kind of jump into some activities and resources you can use and or share with others. While I go through some of these, feel free to share some of your own activities or ask questions along the way. I'm always up for that. And then I also like to leave some time for Q&A at the end. We do only have a half hour and it's going to go by rather quickly, but I also have a sense of humor. So there might be, some shared images and graphics to kind of keep this presentation lighthearted as you see on the screen there. So why teach space science and astronomy? I kind of want to see what everyone is watching today thinks about this kind of right now in chat. Why is this something that we should be teaching in our classroom or at home? What are some thoughts maybe you're having about this topic? I want to kind of leave some time for you to kind of answer that right now. I think that'd be good for everyone to just kind of see. And then also kind of have a good idea for me to also see, what are you thinking? What are some, thoughts behind this as well? So essentially nothing is more important than to us than the earth, right? It's basically that main thing that's up in the air. It's in space. Without the sun's heat and the light, the earth would be pretty much a lifeless ball of like an ice coated rock, right? The sun warms our water, it affects our atmosphere and weather, and gives energy to our plants that provide food and oxygen for life on earth. If that is something that is that crucial, I would think it'd be rather important to learn about. And that's really the why behind the science, space science and astronomy. I came across a quote that said, when something does not insist on being noticed, when we aren't grabbed by the collar or struck on the head by a presence or an event, we take for granted the very things that most deserve our gratitude. The sun, technology, and fresh drinking water are sometimes taken for granted. The value isn't seen or felt until it's not there anymore. Space is more abstract. Rarely anyone goes there physically, so it's kind of hard to relate to and understand completely. But the moon, sun, other stars and planets, meteoroids and asteroids, they are all important. It has a huge value and affects us on a daily basis. That's why I get excited listening and learning more about it. There's this more, interesting thoughts of discovery and fascination of the phenomena out there to witness and explore. And even the general public feels this way, when the news or some event is occurring, because again, it's something tangible. So with that being said, I did want to kind of tribute to the sun in this presentation. And I thought what a cool way to do that is kind of link a video from NASA. NASA did an amazing thing, which I'm always fascinated behind the science and what NASA could do, but their Solar Dynamics Observatory created a time-lapse video spanning a decade from 2010 to 2020. And so that's what it actually looks like. I've kind of circled the date on the screen shot, and I I did that because I just wanted you to kind of see, you can sort of see it, it's kind of fainted. It's a little bit better if you have it on your screen, but you can see the dates, and each second that passes presents one day for the sun. In this video, you can see sunspots, large ones, the magnetic field lines, the solar flares, as well as the other events you wouldn't normally get a chance to see, quote unquote, live. What I've done is added an article as well to there, and that's what you see in the second link there. And that is there, so you can also share it with potentially your students if you're more interested as well, because it's all about seeing the science in action. I think that's where it kind of comes into value. Let me grab the link here. Maybe I can put it into the chat box real quick for everybody, just in case you are interested. But before we move on to the next slide, I wanted to kind of revisit the idea of how we can make space tangible. When we think about making space tangible, one way to do this is with videos and imagery, just like you see on the screen. This usually comes from hobbyists, NASA, scientists, and other enthusiasts. But I want to pause there for a second and just kind of get a feel for how big our solar system is. And I'm going to go to ask you a poll question again. I kind of want you, again, to kind of answer this poll because I think it's important to actually kind of figure out here. Okay. So how far is it from the sun to the end of our solar system? And I want to kind of put that out there for you because I want you to kind of answer. Give me honesty here. Don't worry. This isn't a test. If you don't know the answer, that's okay. Just take a guess at it. But essentially, I really wanted to kind of do this to kind of get a framework of that, like a scale, right? When we talk about the scale of our solar system, how big is that really? What does that actually look like? And so just to kind of get a feel for what you think it is, is it in millions of miles? Is it billion of miles? Is it trillion of miles? What do you think it is? And it looks like we're just about ready to get everybody. So I'm going to end my polls now. I'm going to kind of share my results. So majority of the people thought it was actually 5 trillion, and that is the actual correct answer. So if I go to our next screen, it is 5 trillion miles away when we go from our sun to the end of the solar system. It is just absolutely huge. And so when we think about, what does that actually mean to students? I don't think 5 trillion miles is really something comprehensible, let alone like 1 billion miles when students are in elementary and middle school or even younger. I mean, the earth isn't even 8,000 miles wide. So how do we actually explain that huge scale to students? Well, we more or less simplify it, right? So we actually use something called the astronomical unit, or AU. And I've added a link to a video below the title of this slide that you can use to kind of explain this distance in a more meaningful way to students using AUs on a football field, something that students can kind of connect with. What does that AU mean and how does that actually connect to me? But I kind of want to switch gears from here and kind of start to think about the different activities that you can use with teaching space and astronomy. And I believe everyone, or at least most of you, have heard the acronym STEM or know what it stands for, but I also like to use STEAM and include the arts. But regardless of what you have heard, what you use, I wanted to reiterate the importance. If STEM or STEAM done right should be an educational experience that creates space for students to ask questions relevant to them as they experiment, test theories, consider a range of outcomes, and choose to ask, how could I, how would I, why should I? And a key component of that is science and math. So I have a poll I kind of want to take with you again, just to kind of re-engage you a little bit. And I'm going to launch that now. And I kind of want to know, what do you believe in, right? If you had to choose one area, which part of STEM would you consider to be the most important? All right. And there's no right or wrong answer here. It's just more or less what you believe. What do you think out of these areas would be the most important for STEM? And unfortunately, you can only choose one answer. And I know this is a science webinar, but don't feel like you have to answer one way or the other. I want you to really base it on what you think, not what you're feeling or what your gut is telling you. It's just really what you believe is the correct answer. Or, the most important, I should say. There is no correct answer here. All right, so I'm going to end polling and I'm going to share the results. So we kind of have a little bit of a mix here. So we have a little bit of science, a little bit of technology, and then there's even individuals that was thinking maybe engineering and math as well. And that's okay. That's totally perfect. I kind of wanted you to kind of use that to kind of get to that next phase. The reason I really wanted to take that poll is it kind of leads to my next point. When we teach space science or astronomy, we really have to start to move away from, the research or the visuals and really allow students to be hands-on in a meaningful way. And if we were in person, I would love to work with you hands-on on experiences to kind of drive my point home. More about the learning doesn't happen until it's tangible. Space is abstract and we need to make it tangible. Science kind of helps explain real world phenomena, those abstract concepts. And if you're following me on this path, this will definitely help explain my final point. Math is the language of science. And this is sometimes a hard concept for some people to grasp because we're taught usually early on in our lives that science and math are different. If you're teaching math, you teach math, not science. And that's how schools often see it too. And they kind of segment it as such. But yet you have this, you probably heard that, those that do well in math usually do well in science as well. And there's a reason for that. It's because math and science tie very closely to one another. Math literally explains, it communicates all the science around us. Think about it. Gravity is explained mathematically. The periodic table of elements can be explained mathematically. Our theories and laws of science are tested and tested using data, using formulas and a series of repeatable experiments. Science could not exist without math, and the sooner we teach students this, the sooner they can begin to appreciate the subject as well, both of them. Appreciate the opportunity to understand, human traits, puberty, our ecosystems, etc., which can be explained with genetics, again, tied to mathematics. When there's a lot of emphasis on math at the elementary level, this is also the beginning of their understanding of science, and there's this natural connection between the two. This is a critical part to really incorporate math into a STEM or STEAM program. And I purposely wanted you to take that poll and choose one answer because I want you to force you to think about what you find most important. Maybe you have a bias, maybe you don't. But it's important to remember that students also come with biases and misconceptions. And as educators, we really need to understand them and know how to help students to learn and reflect on them. So we can see the connection between science and math, and you can probably see where there's an easy connection between engineering and technology, but all these components together essentially lead to real world application. It's about understanding the real world around us. And when students learn about science, technology, engineering, and math, art, and mathematics, we're also teaching lifelong skills like critical thinking, communication, collaboration, and creativity. When you see a home, you know that there was thought and planning around the design, the siding, the doors, the windows, the whole makeup. When you see a piece of art, that you see there's creativity, but you also receive expression and emotions when viewing something for the first time. When you see technology and use it day to day, it's easy to forget how much effort and thought went into that piece of technology. And you might say, "Okay, Jordan, I get this. You're kind of preaching to the choir, but what I'm really trying to hit home here is that students don't understand this. We sometimes forget, just like the sun, learning a new skill for the first time and how much patience it takes to fully grasp a new concept. We sometimes forget to share or tell those closest to us how we really feel. Math and science is all around us, and we sometimes forget to point out the quote unquote obvious examples right in front of us. Science and math is very powerful. When we have to be that guide to help students uh, build with that strong foundation. And STEM and STEAM essentially ties what we learn in the classroom to real world applications. What we see every day is a combination of these different areas. So now I'm kind of going to switch gears and kind of start to jump into different lessons and activities you can use for space and astronomy. But you can also notice a common theme among them. They all incorporate some sort of STEM STEAM application, and I'm sure some of you might be familiar with STEM STEAM, but each of these lessons incorporate the engineer design process. And this might have another name at your school, like the engineer design cycle, or there might be different steps that are similar to what you see on the screen. But essentially, it's a process which we solve real world problems, small or large. This should be hold true to any math problems or science problems you do in the class. More often than not, a student is going to ask, "Hey, Mr. Nelson, why are we learning this today? Or why do I need to know that?" And my first response is to that, "Thank you for asking," because I want them to know that it's okay to question what they learn. they have that right to take ownership in their learning. And of course, you'll have some students that ask just to ask. They'll, they kind of really don't care. But if you show your passion and you're legitimately explaining the why, it'll start to get to students to continue inquiring about what they're learning and to continue asking questions, but also show how relevant everything is to everyday life. Those difficult physics, questions that seem so abstract, but relate to a rocket ship going into space and re-entering the atmosphere have everything to do with science, technology, engineering, and art and mathematics. Understanding the why allows students to really appreciate and empower students in their learning. Now I'm just going to kind of look at time check here. Okay, so we're doing okay on time. The next piece that comes down to educator. The teacher in the room that has the patience, the experience, and know-how that might be, some discomfort in trying something new because we don't know how the outcome before we begin. And you might be trying different teaching strategies that you have not done in the past, but you have to be thinking about the bigger picture. When you incorporate summer STEAM, it has to scaffold. Everybody have the same mission, vision, values in order to make that program successful. Because ultimately, we want students to be able to take the skills and knowledge that they've learned and apply this to the real world. It's really about that authentic learning, the why. Why are we learning algebra? Why are we learning about space? Why are we learning about, or learning how to read and write? If you can answer those questions for students, it's very impactful. So now we're going to quickly go through a lot of the fun part, the activities. I know a lot of the front part is talking about the whys, but I think that's really essential to set you up for success. So covering today, are going to be more or less course space themed, ranging in all different grade levels. And these activities aren't in any specific order. They can stand alone, be supplemental, or complementary to what you already do. The first activity is, kind of creating an informational book. You've probably seen this before, but it's a common thing that you can do for students to really start to learn about space, right? And so your first page is outer space. Then you get into your second page, there are 9 planets. And this can be, set up where they're all spaced out accordingly with the rings or their the rotational axes around the sun. And then you can also get into the actual size of it. So this is done at the elementary level that, it's got the print that there are 9 planets. So it's getting students to get familiarized with this. And then, hey, there's the Earth. It is our planet. How does this explain everything? Well, there's also the sun that is a big player in this. It is a star. Well, what is a star? Then you get into astronauts in space and thinking about career paths. If students are setting themselves up to be successful and start to think about how does this relate to real world applications? Well, there's astronauts, there's physicists, there's all kinds of career paths that are there. And we want students to start to think of themselves as opportunities of other different careers that they could potentially discover or participate in. Then you could talk about the rocket aspects. Well, how do we get to space, right? And then you can get into the counting and the numbering. And so this is just an example at the elementary level, but you can certainly take this at the higher level, the middle school level, if you were saying, okay, you have to put yourself in a situation where you're a lead teacher and you have to help educate your younger sibling or a student, and you need to create a 6-page book explaining our space. So you kind of leave it open-ended for them to be able to do this, and then they can research, well, what do they find important? You're going to find out really quickly what is important about space. What are the main facts that they want to highlight about this? And they have to explain it to someone younger than them. But it has to be, they could be artistically done. It could be via video. It could be via a song. There's a lot of ways that you can incorporate this kind of activity. You can also create something called a Zoom book. So Zoom book is also talking about scale. How does this relate to our solar system? The example you see there is pages from a kindergarten's hand-drawn Zoom book. It's inspired by a shell. So at the very beginning, there's this large shell. And then as you back out further, you can see that it's not so large anymore. It's actually back. Well, what are those lines? Well, you zoom back out farther, you see more lines. Well, then as you zoom back farther out, now you can see there's like this field and this grass and other different applications. So even though the shell might seem very large at first, in the bigger picture, it's quite small. The same thing with Earth in our universe. It's almost 8,000 miles wide. It's huge, right? But if you put it in the bigger scale, it might not be as big as you think. And so that's where the Zoom book can come in handy. And I also added a little link there for you to kind of see. It's called Zoom by Iston. And so basically it does the same concept. It has like these red hills, and then it zooms out, and then eventually you see it's a chicken. Well, then it zooms out further, and then you see it's a chicken on a book. So it's actually a book. And then you see a grandma or somebody reading this book. And then you zooms out further and you see kids looking in to a barn where they're actually reading this book. And it keeps zooming out further and further. And it kind of gets you into that perspective that even though things might seem large or big, it might be small in the bigger picture. And so it gets them to start thinking about the universe and scale and size. How does that look? You know, with younger students, you can use, a think aloud with them and come up with questions like, hey, why did you put this picture with this one? Or what was your method for organizing these pictures? You can create your own images and have students organize them together. What did you find challenging? Things of that nature to really get them to start thinking about scale. You can use, of course, your alphabet book, ABCs, virtual. That link right there, the NASA actually has images, dictionary. So if you have an astronaut, here's a picture of an astronaut. If you have a comet, here's a picture of a comet. And you can get to students to start thinking visually with the actual vocabulary. Same thing with older students. You can come up with your own alphabet book, and then the students have to actually come up to be able to use with their vocabulary. Then, of course, you can come up with songs. The family of the Sun song. I don't know if people have heard that before, but it kind of goes something like this. Let me grab that real quickly. The family of the sun, the family of the sun. There are 9 or 8 planets in the family of the sun. And so you can keep going on to add more planets. Mercury is hot and Mercury is small. Mercury has no atmosphere. It's just a rocky ball. And so you can add and modify this. Now that link right there kind of has some fun, little different voice and did a little bit better than singing than I do, but it kind of gets the same kind of point home that you can kind of create some fun songs or literature around also space or astronomy as well. Also, creating themes, this experience for students is also very popular, right? So you've all seen that where they kind of had their thinking caps on. Well, create an actual helmet for them. Here's a little template, that you can utilize with your program, that they can actually become astronauts, right? Or another way that you can utilize this is creating, a control center. Hey, we have a control center with a rocket ship here, and then see the student there with a little cutout. Well, you could put a crate down, they could take pictures there, something for them to actually engage with, starting to think about actual careers. And so we also have right there, as you see there, the little doll, that's a Roxy Hart doll example, but she has like a star skirt on. So you can talk about themes and just dressing up for occasions, just like we do for maybe like a Halloween or some other holidays. Same thing with our characters that we do stories with puppets, other different characters that we want to incorporate with literacy. You can use that as an engagement components to kind of enrich the student's experience. You also can do some 3D printing and decorations as well. There's a diorama that could be utilized with that. You can use that for scaling. Also to the left, glow in the dark. So those are actual pieces that have been 3D printed. So you can use templates for like a 3D printed pen or other 3D printed projects. Use some glow in the dark paint them, and then put them in your room, or explain how you can use those for other different applications, right? So just things to really enrich the experience for the students. Then you can come up with different challenges. So in this case, the challenge is called Hit the Target. The background is, hey, thanks to NASA, the moon is getting a new crater. NASA is sending a spacecraft hurling into the moon's surface. Why? To see if there's water below the surface. This collision will send up a plume of dust and gas over 6 miles high, right? And to tell if there's any water, scientists will look for ice crystals and water vapor in this plume. So your goal here, more or less, is to modify a paper cup so that it can zip down into a line, and drop a marble onto a target, just like it would be hitting the moon, right? And so students kind of follow the engineer design process to modify a cup to carry a marble down the zip line. They attach it to a string to tip the cup, And then they test the cup by sliding it down the zip line, releasing the marble and trying to hit that target on the floor. And as you can tell or know, that first time they're going to do this, they're going to probably fail, and that's okay. But they are going to give them the opportunity to improve their system based on their testing results, just like they would in real life here. All right. And I did just receive a question from Susan saying, "Hey, it came in, and I just wanted to make sure, can we access these slides and links?" Absolutely. At the very end, I'm going to be able to send these slides and other links to everybody afterwards, so you will have access to this as well. Um, Next challenge here, build planets to scale. So this is kind of fun because it kind of brings back to that whole making things tangible. We want students to show how we kind of build a model, right? So if we had Earth that was 3 inches in diameter, and then we have to create the rest of the planets to scale based on the size of Earth, talking about ratios, talking about actual size. You can use AU units, you can use metric, you can use standard units, however you want. So this is a nice way to get students start to thinking about scale, right? So if Earth is actually 3 inches big, how big would Saturn be? How big would the sun be? What would that actually look like? And then putting that up in front of them kind of gets in perspective like, wow, I didn't realize how big Neptune was, or wow, I didn't realize how big Jupiter was. Things of that nature is going to really start those discussions around the space and how is this actually tangible for them to actually understand the concepts. Then I also wanted to kind of get into a rubric. The reason being is because oftentimes when people start doing project-based learning, or they have a project that they want to do, sometimes they struggle with, okay, what is the rubric? What can I use to actually use for an assessment piece? So I actually included just a basic rubric there based on creativity, because we want them to get, thinking about the different outside of the box, not just something that is already existing. So this might be one way to critique them. Iteration, right? How many times did they improve it? It's usually that first design doesn't go as well. That initiative, did they keep working through those mistakes, that frustration level? Because at work, you're going to have those times just as well. As a teacher, you went through a lesson plan, you did it, it didn't go as well. Well, that could be frustrating because you thought you had everything covered, but maybe you missed that you needed to have a worksheet, or you forgot it at home, or technology wasn't working that day, etc. Then the learning opportunity, right? So they have to learn about the content themselves. Did they actually learn from this around the subjects and around those standards? And then, of course, usually there's a real world application, and that's why community is built in there. But that's just one example that you can utilize with your school or your system. I figured I'd give that as an example. Then I'm going to get into kind of like teaching strategies. I am kind of close here. So I'm going to kind of go through this a little bit quicker. But essentially, not making mistakes to feel excluded is very common, even myself excluded, right? No one wants to kind of stand out. We've all been there before. Uh, but we want to be able to give students the opportunity to make mistakes, and many of them, because that's when we actually start to learn, right? So every time this happens, it's like talking to someone else in the language. Hey, we want to be able to use that to further their understanding. So I might give my students 1,000 beads every time they make a mistake. Oh, give me a bead. Well, you can keep giving me beads all day because you're more than willing to, make those mistakes, right? We're all about that. And the students would feel like, oh yeah, I can make mistakes. I can make mistakes all day long, but we have to see the learning along with that as well. And then students want to learn, but they kind of hesitate, to practice because they're afraid that they might fail. This is huge right here. Failure, leads to great achievement though. And we want getting students to really start to think about, um, you know, not feeling isolated or insecure about their own self-worth when they make mistakes. Our natural instinct is to, avoid social exclusion, um, you know, because we want to be a part of the group. We want to be a part of everybody. But, this is usually accentuated in school where, most questions have right or wrong answers, and we're praised on achievement rather than effort. So it's important to kind of keep this in mind when we're trying to think about making mistakes in the learning process. And of course, try again with emphasis, learn from mistakes, making learning size mistakes, just like this graphic here. When a building a spaceship, the tiniest details are crucial. For example, this spaceship may be flawed because it has a giant hole in the side. That is true. It's very common, right? And so we have to kind of start thinking about that. How can we learn from our mistakes? What are some things that maybe students take literal that we have to kind of talk about, or the misconceptions that they have, and that every great achievement started with the failure. So all those things are definitely important. Some things I wanted to kind of also touch on as well is, things to consider, resources and ideas. Ask an astronomer. If you're not familiar with some basics of space, if you switch from teaching math course into science and you're just not familiar, ask an astronomer. Here's a link you can quickly go to. It can really tie into what is volunteering, because a lot of people at those websites have kind of rules and guidelines of what you should be doing or not doing, kind of like an etiquette. You've heard of etiquette before, but that's kind of more a way of accepting, a way of communicating on the internet. But that's another great skill you're teaching students as well. When you're asking somebody a question, what is the proper etiquette of actually going through the process and asking for advice or working with somebody on the internet? Just like there's probably a certain etiquette with texting or social messaging, when you're doing it at school versus with your friends. Same concept there. Then you can get into creating your own interactive sky chart. This is very popular. This is things that you can do in the classroom, and then they can engage with this at home or after school hours as well. Creating your own moon phases, calendar, and calculator. This is another great way, an activity that you can engage your students with that can be very impactful, that's relevant to them, because you can do it in that's specific to their time. So if I'm 5 o'clock in the evening, where are the stars alignment right now? Where are the moon phases on the beginning of the month or after the month? Citizen science. This is another great way to get engaged with science outside, especially with astronomy and space science, because oftentimes this is an extra, especially when you get into the high school level. But this project here, Backyard World Planet 9 project, this is from SciStarter, and there's a link to that. But this essentially led into people discovering brown dwarfs out in space, right? And they used the volunteer help based on people using citizen science. Those scientists and astronomers and things of that nature are already familiarized and know kind of what they're looking for. And sometimes they kind of miss things because they already think like, oh, I already know what should be in this area. So having the help and assistance and building with the community, you can really show the power of citizen science. Also, another activity that you can do, globe at night, talking about light pollution. A lot of people think, oh, what is light pollution? Is that even a thing? Well, certain animals and species navigate at night, and depending on how much light is emitted from a city or things of that nature, that can also affect just the environment, just in general. So, starting to think about those different aspects that maybe otherwise they haven't thought of can really help. Also using news and events to help drive interest or activities, like this little article here talking about volcanic activity on Mars. Is this a thing? There's some suggestion and evidence that it might be. And so just like with coronavirus, when this first came out, we didn't know everything about it. But over time, through testing and communication and just using that science just and every day, they were able to figure out more and more about it. Same thing with space. They're starting to learn more and more about Mars right now. A lot of information. Then, of course, Astronomy Day. If you haven't thought of it, it's actually coming up. Maybe you want to do some activities. There's different phases. Maybe you want to do it in the spring, or maybe you want to do it in the fall. There's different dates. And then there's also kind of like Astronomy Week that you can kind of, conceptualize different activities along with these. Some different events throughout 2021. I wanted to quickly show that as well, just in case you're interested. And I also have some in-depth events calendar throughout the year, in case you're like, hey, is there half moon coming up, or there's celestial moon, other different events throughout the year that you can quickly go to kind of help you engage your students as well. All right, I kind of went through a lot really quickly. I know I definitely hope that you gained a lot from this. I am a little over, but I wanted to also thank you for your time and joining me. My name is Jordan Nelson. I'm one of the customer engagement managers with Nasco. If you have questions, you can ask them at this time as you're writing them. I'll start to get the handouts loaded out and the webinar control panel eventually. I think at the time, oh no, that's right. GoToWebinar used to have that feature, and then we switch over to Zoom. So what I'll do is I will follow up with everybody afterwards. But I did want to reiterate that there will be a survey after this webinar. Please take the time to fill that out. If you're watching the recorded version of this, please reach out to me at engage@nascoeducation.com, like you see out there on the screen. I'll get you all the documents and information. But you also should be receiving a follow-up email with a lot of these links, the presentation itself, so you can reference this and use it in your own classroom too. If you like this webinar, go to nascoeducate.com and you can sign up for your free account. This is a great way to be able to see what other future webinars are coming up with. And in case you are interested in the next version of the Next Generation Scientists, I'm going to look over real quickly in chat and the Q&A just to see if there's any other questions. I don't see any at this time, so I'm assuming everybody got everything that they needed. Again, thank you so much. Like I said, it was only a half hour. It went by really quickly, went a little over, but I like to try to get as much information as I can in a short amount of time. So thank you for joining me. I hope you enjoyed this session for Next Generation Scientists exploring space science and astronomy. I hope you learned a little bit and enjoy the rest of your day. Take care, everybody.